Hello year one and welcome back to Tuesday's Maths. Okay, so we're having a think today about number bonds to 20. But before we do that, let's have a little think about what we did yesterday. So yesterday we were thinking about adding by counting on, weren't we? Not counting, also counting on. We had a question like this yesterday. Sam starts on the number 14 and he counts on 4. Where does he land? And what's the number sentence? So you did a super job with this yesterday. So let's just do this one together. So he starts on the number 14, which is right here. Then he counts on 4. Okay, so that's how many jumps we'd like to do. So let's do 4 jumps from 14 together. Can you count with me? Ready? 1, 2, 3, 4. What number have we landed on? That's right, we've landed on the number 18. Brilliant. Okay, so we know that 14, which is one of our parts, add 4, which is our other part, which is what we were counting on, equals our whole, gives us our whole number, which is the number 18. So 14 add 4 equals 18. Can you say that with me? Ready? 14 add 4 equals 18. Superstars. Okay, so today, as I just said, we're going to be thinking about number bonds to 20. So before that, we're going to think about a number bond to 10. So it says, question 1, what number bond to 10 is represented by the 10 frame? So we've got a 10 frame here, and we've got 3 stem sentences and a number sentence that we need to complete. So let me read them to you. There are something black counters. There are something red counters. Altogether, there are something counters. Something add something equals 10. Okay, so your job is to be able to fill in those stem sentences and tell me what the number sentence is. Now, I know you're really good at your number bonds to 10. We practice this a lot in our big maths, don't we? So you should be able to tell me what number bond to 10 is represented by the 10 frames. So I suggest you ask somebody at home to help you write these 3 sentences down, and you can fill in the missing numbers and write me the number sentence, okay? So I'd like you to pause the video and have a go at question 1. Okay, brilliant. So hopefully you've had a go at question 1 and you've counted how many black counters there are. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 black counters. How many red counters are there? That's right, there are 2 red counters. Oh, I don't know how I've got it to go black now. Let's try and get it back on red. There are 2 red counters. Altogether, there are something counters. Well, I've told you we're trying to find the number bond to 10. I've also given you a little clue here. And we can see a full tens frame, which means there are 10 counters altogether. Brilliant. So now we can see our part and our part and our whole. So we know our number sentence is 8 add 2 equals 10. Can you show me that with your actions with me? Ready? 1, 2, 3. 8 add 2 equals 10. Fantastic. Okay, so if we know that 8 and 2 and 10 are missing numbers in our stem sentences, and 8 add 2 equals 10, let's have a look at this one, question 2. Now at the top of the screen, this is what we've just worked out together. There are 8 black counters, there are 2 red counters, and altogether there are 10 counters. Now this time, it says what number bond to 20 is represented by the tens frame. So this time there are 2 tens frames. They're both full, aren't they? So how many do we have? If we've got 2 lots of 10, how many have we got? We've got 20, haven't we? 10 and 10 makes 20. So this time we've got 3 stem sentences, again exactly the same ones, and we've also got a number sentence with some missing numbers. Okay, so question 2, exactly the same as you did with question 1. Maybe ask a grown-up to help you write down those 3 stem sentences, and you can fill in the missing numbers, and we will see what we get. Okay, so pause the video and have a go at that now. Brilliant. Okay, so there are how many black counters? Shall we count them together? 1, 2, 3, 4, 5, 6, 7, 8. 8. Brilliant. There are 8 black counters. How many red counters are there? Well, to count our red counters, we could count them one by one, but we know how many is in this one. There are 10 in that one, aren't there? Because this is a full tens ring. So should we count on from 10? Should we put that 10 in our head and count on? So we've got 10, 11, 12. There are 12 red counters. Altogether, there are how many counters? There are 20 counters, aren't there? Because we know that there are 2 full tens rings and we've got 20. So what's my number sentence then? My number sentence is 8 add 12 equals 20. Now I'd like you to have a think about this number sentence here, which is showing this tens frame, and this number sentence here, which is showing the representation of these tens frames. What do you notice about them? I'd like you to have a little think and maybe have a chat with somebody who is at home with you, or have a think on your own, or if you're at school, have a talk with the people next to you. Okay, so pause the video now to have a go at that. Brilliant. I wonder if you notice that the number 8 has stayed the same for both of those sets of stem sentences, and the number 12 here and the number 2 here. 8 add 2 equals 10. 8 add 12 equals 20. Can you see now, year 1, how our number bonds to 10 will help us with our number bonds to 20? Can you see that? Okay, let's have a look at the next one. Question 3. So now we're just thinking about this number bond to 20, but there's also the number bond to 10 up here that might help you. Okay, so again, there are 3 stem sentences and a number sentence. This is question number 3. So again, also grown up to help you write down the stem sentences and you can fill in the missing numbers. Okay, there are something black counters, there are something red counters, all together there are something counters. Something add something equals 20. Okay, so pause the video and have a go at question number 3. Brilliant, okay, year 1. So how many black counters are there? Let's count them together. 1, 2, 3, 4. There are 4 black counters. There are something red counters. Now again, let's put that number 10 in our head instead of counting them all. We practiced this yesterday, we practice it all the time. There's 10 counters here. Let's count on from 10 and count the rest of the red counters. So show me 10 and pop it in your head. 10, 11, 12, 13, 14, 15, 16. So there are 16 red counters. How many counters are there all together? Well, we know, don't we? There's 2 full tens frames, and 10 add 10 makes, brilliant, 20. So what is my number sentence? Something add something equals 20. Brilliant, I've got 4 add 16 equals 20. Now, have a little look now at our number bond to 10 up here in this 10 frame. What number bond can you see? I've got 4 black counters and I've got 6 red counters. So 4 add 6 equals 10. So can you see again how our number bonds to 10 can help us with our number bonds to 20? Because look how similar this number sentence is. 4 add 6 equals 10, but 4 add 16 equals 20. And can you see how, look, there's 1 10 here, and there's not a 10 here, is there? There's only 6. But as we've added a whole other tens frame, we've added a 10. So 16 has got 1 10 and 6 ones. So it's really important that we know those number bonds to 10 because they help us with our number bonds to 20. Brilliant. Now, question 4. Got no stem sentences, just the number sentences, and this time I'd like 2 number sentences. This first tens frame here is representing just a number bond to 10, and our second tens frame, or second 2 tens frame, second number sentence is representing a number bond to 20. So I wonder, can you find out for me what number sentence is shown in this tens frame? How many black counters, how many red counters, and then see if you can use that number sentence to help you with this number sentence without having to count the counters on this one. Okay, so you can count the counters to help you, or you could maybe go back and double check, but see if you can use the answer to this one to help you with the second one. Okay, so that's question 4. So pause the video now to have a go at that one. Fantastic. Okay, so what number sentence can I see here? Well, I've got 1 black counter. And I've got how many red counters? What do I add to 1 to get 10? That's right, I add the number 9. So what's that number sentence there? 1 add 9 equals 10. We know that, don't we? We practice all the time. 1 add 9 equals 10. So now, what number sentence do you think I can see on these two tens frames if I use this number sentence to help me? I've still got 9 red counters. I'm going to pop the 9 in. But it's not 1 that I'm adding because that would still give me 10. I've got how many black counters? I've got 11 black counters. Can you see how I've just added 1 10 to my number 1 and I've got the number 11? Can you see that? Because there's an extra 10 here. Because if I covered up this first part of the tens frame, covered up the first tens frame, you've got 1 and 9. And if I then take away this box, I've got another 10. So I've got the number 11 add 9 equals 20. So can you see again how we can use our number bonds to 10 to help us with our number bonds to 20? Okay, right, there's one more question to have a go at. Question 5. Again, it says use the tens frames to write the numbers, and it's exactly the same as the last one. I wonder if you can use your first number sentence, your number bond to 10, to help you with your number bond to 20. Okay, so you should have 2 numbers written down on, 2 number sentences written down. So pause the video and have a go and see if you can get those 2 number sentences. Brilliant. Okay, so firstly, I can see what number sentence up here. What number bond do we know? Oh, we know that 8 add 2 equals 10, don't we? We can see 8 black counters and we can see 2 red counters. 8 is one of my parts, 2 is one of my parts, and the whole is 10. So if using that knowledge, I can still only see 2 red counters. How many black counters have I got? Something add 2 equals 20. But if I know that 8 add 2 equals 10, super, I know that 18 add 2 equals 20. We've added an extra 10. If there's just 8 ones here. On this one, I've got 1, 10 and 8 ones. You can see that extra 10. 18 add 2 equals 20. Brilliant. So it's really important to know those number bonds to 10 as they help us with our number bonds to 20. Now, Superstar Maths Challenge today, if you're feeling up for the challenge, I've got a bit of a reasoning question here. That means you need to use your thinking and be able to explain your mistake. Not explain your mistake, explain your thinking to show the mistake. Okay, so it says, Jack represents a number bond to 20 in a part-whole model. Can you spot his mistake? So remember, when you look at the part-whole model, you have part equals whole. So if you think you're up for the maths challenge, pause the video and have a think. You don't need to write anything down. You can if you'd like to, but you could just have a chat. Okay, so remember, if you are going to write it down, you can explain by saying, I know this because, we use that word because to explain our thinking. Okay, so if you'd like to have a go at that, pause the video now and I'll have a chat with you afterwards. Brilliant. Okay, so Jack has got the number 20 in his part-whole model. He's also got the number 13 in his part-whole model, and he's got the number 7. So that would give us the number sentence 7 add 13 equals 20. That's correct. But what's wrong with where he's put the numbers in the part-whole model? So I know that 7 should be a part, and 13 should be a part, and 20 should be my whole. So have a look at my part-whole model. Where has he put 20? Oh no, he's put 20 in one of the parts, hasn't he? So he's got that 13 is the whole. So he just needs to swap his numbers around so that he's got them in the correct place. So 13 is a part. So should we change it for him? Let's just cover this up. So 13 is a part with our 7. Pop that there. And our whole is 20. So he got all the correct numbers, but he just got them in the wrong place. So well done if you got that right. Really great maths today, year 1. Don't forget to put those pictures on Class Dojo so that I can see your wonderful maths work, and I will see you again soon. Bye, everybody.